Okay, so this time we are also converting from base 10 to other base. In the previous one, we converted from other bases to base 10. So in this case, we are only converting from, we are doing the reverse. Okay, good. So you can be asked to convert from base 10 to base 2, base 5, base 4, base 8, whatever base. Okay, yes. So let's take examples and see how we can go about it. All right. Okay, so we are to write 259 base 10 as a number in base 8 or octal system. So in the question, you can either be given octal system or base 8. When we say base 8, is the same as what when we say what octal system. So note this: the moment you see octal system, note that we are talking about what? Base 8. It should be in base 8. Good. So how we convert from base 10 to other base is different from how we convert from other base to base 10. So this one, we are going to use a different approach. In that case, we are going to use what we call the remainder principle. The remainder principle, that is what we are going to use. When you are asked to change from base 10 to other base, you use the remainder principle. So what you do is you need to divide whatever number here, you need to divide it by what? The given base, not the one that is base 10, but whatever base you are to convert to. Okay, so here we are to convert this to base 8. So it means that we are going to divide all this by the what? Base 8 and write our remainder. We will divide until you get to a point where you cannot divide again. Then we use the remainders that we get, that will be used as our answer. So let's see how we can do that. So when it's given to you like this, what you do is you can write the 8 here and then write the 259. Then you can write your remainder. So let me use R to represent my remainder. Okay, good. So let me draw a table form like this. Good. So this table form, this is what we are going to do. So in the first place, you ask yourself, 8 divides 200 and or 8 divides 259, how many times? How many times? That is the question you should ask yourself. So if 8 divides this, how many times? I know we are going to get 32. And what will be the remainder? It means that 8 multiplies what? 32. We get a certain value, which we can get from this, and then we write our remainder. So what will be our remainder? The remainder will be what? 3. Okay, so it means 8 divides 259, 32 times, remainder 3. Then you continue like that. You write the 8 here. So you realize that this 32 is still bigger than 8. We can still divide. So 32 divided by 8, how many times? 4. Remainder what? So you realize that 8 can divide 32 equally without a remainder. In that case, remainder 0. Okay, now so you see that we have 4 here. Okay, we have 4 here. Now if the 8 to divide what? 4, you see that 4 is less than 8. So if we are to divide 4 by 8, we are going to get 0 point a certain figure, which that will be a remainder. So there are times that when you get here, because the number is less than the 8, you can end it there and start writing your numbers from 4 upwards. But there are times that you can also divide this, you will still get what? 0, remainder 4. It means that if I should divide 4 by 8, I'm going to get 0 point something. 0 point number, it means 8 will divide for 0, remainder what? 4. Good. Now once you are done, then you are going to start writing your numbers from here, downwards, upwards, from the down to the top. So most of the time we use this arrow. What this arrow means is that you start from down to the top. You are going to write your number, so it means you are going to get 403. That is how we write the number. We don't write the number from the top downwards. We write from downwards to what? The top. Okay, good. If that's the case, then you can conclude that therefore 259 base 10 is equal to 403 base what? 8. You were asked to change it to base 8. Exactly. So that is how we change from base 10 to other base. Let's take another example and see how we can do that one as well. So in the example 2, we are to change 19 to a binary number. Now you see that there's no base here. As I said, whenever you see that the number stands alone without a base, know that it is in base 10. So there are times that we don't even write the base when it is in base 10, because at the end of the day it gives the same number. So it is in base 10, and we are asked to change to what? A binary number. When we say a binary number, what base are we talking about? Now note that the moment you see a binary number, you are talking about what? Base 2. Okay, base 2. It means you have to change to base 2. Okay, so binary numeral is the same as what? Base 2. So take note of that. Alright, so it means we are going to change this to base 2. Already this is in base 10. So what you do is you write your 2, you write your 19, and then you write your remainder. So in a table form, good. So 19 divided by 2, how many times? So it means when 2 divides 19, how many times? You are going to get what? 9, remainder what? 1. So it means when 8, 2 multiplies 19, it will be what? 18. Okay, 18. So 19 minus 18 is 1. That will be the remainder. Okay, good. Now 9 is still greater than 2, so we can divide again. 9, so 2 divides 9, how many times? So we can say that it is 4, remainder what? 1, because 2 times 4 gives me 8. If I subtract 8 from 9, I'm getting what? 1. That will be the remainder. Okay, great. Now 2 here can also divide 4, because 4 is greater than 2. Now 4 divides 2 divides 4, how many times? 2, remainder what? 0. Okay, yes, so move on like that. Now the 2 and 2 are the same, so still it can divide. Okay, yes, so if 2 divides 2, how many times? 1, remainder what? 0. Okay, good. So you realize that now you have 1 which is less than 2. So if 2 divides the 1 again, you see that it's less than, so we get 0, remainder what? The 1 again. Okay, good. So once you are done, then you are going to write the numbers from down to top. Okay, so it means that it's going to be what? 1 0 0 1 1. We can write our answer as what? Therefore 19 base 10 is equal to 1001 1 base what? 2. So it is very simple, isn't it? Yes, it is very, very, very simple. Let's try another example, last example on this. Okay, good. Let's try another example. Good. So this example 3, we are to convert 659 base 10 to base 12. Now, before we do that, let's take note of this. Now, in a number base, when you divide and you get 10, let's say 10, or you get 11, okay, you realize that maybe because you have 10 and what 11, which is less than 12, you want to write, you cannot write the 10, because if you write 10 as 10 and you write 11 also as you write 11 as 10, someone may treat it as, looking at this example, someone may think it is 10 and here too it is 11 in, so meanwhile it is not 10, it is 10. So to differentiate them, to differentiate that, or to identify or to know that that particular value, this is 10 or this is 11, we use letters to represent that. So 10, we know that 10, when you are writing 10, it begins with what? T. So we use T to represent what? 10. And we use what? 11 also, when you are spelling, it begins with what? E. So we use E also to represent what? 11. So take note of that, okay? So that when you are writing your answer, if you get 10 and 11, you don't write it as 10 or 11. Other than that, we may think that it is 1, not 11. It is 1, 0, not 10. So we use T for 10 and we use E for what? 11. For instance, let's say I'm writing this number. Let's say I have 10, 11, then 2, 1. Because I know this is 10 and this is 11, I need to write this T, E, 2, 1, so that it will tell me that, oh, okay, so this is 10 and this is 11. But if I don't write it like this and I write it in this form, 10, 11, someone reading it may think that it is 10, 11, 21, which will make the whole thing what? Wrong. So take note of that, okay? If that's the case, then let's proceed and convert this to base 10, base 12 rather. So I'll write my 12 here, then I'll write my 6, 5, 9, and then the remainder is here. Then I'll put them in a table form. Good. Now let's proceed. So 12 divide 659 how many times? So if you divide, you realize that you are going to get 5, 4, remainder what? You are going to get remainder 11, okay? Because you realize that 11 is less than what? 12, so 12 cannot divide 11 again. Good. But here 54 is greater than 12, so we can divide again. So 12 divided 54 how many times? Is going to be what? 4, remainder 6. Okay, good. So you realize that the 4 is less than 12, so if you divide it, you are going to get 0, remainder the 4 again. Okay, then you bring your arrow here in this form, meaning that you are going to write from 4 upwards. Okay, so this is what I'm going to write. So the answer I'm writing is 4, 6. So you see that now we have 11 here, but it's not 11. So instead of writing 11, I will write the letter E to represent what? 11. So this is what I will write. Because if I write 4, 6 and think this is 11 that I've written, no, someone may read it as 4, 6, 1, 1, but not 4, 6, 11. But if I write it like this using the letter, then that person will read it as what? 4, 6, 11. Have you gotten that? Good. So you can then conclude that therefore 6, 5, 9 base 10 is equal to 4, 6, 11 base 12. Okay, yes, base 12. Okay, so take note of that. Okay, yes, base 12. Good. Or let me cancel it and write it nicely here. So let me write it nicely here. 4 6 11 base what? 12. Good. So that is the answer. Okay, so when you are asked to change from base 10 to other base, that is how we can go about. So in our next video, we are also going to look at how we can convert between bases, different what bases. Maybe in this time it is not in base 10, okay, but you have other two different bases and you are asked to change from one base to another other than what base 10. Okay, for instance, you can be asked to change from maybe base 2 to base 5. So you realize that all of them are not in base 10. So in our next video, that's what we are going to look at. All right, okay, so we shall end here and continue on our next video. All right, thank you.